What is up, mathletes? So let's go ahead and let's look at prime factorization. And what we're going to be using are factor trees. All right, so why do we use this and what is it used for? Well, we're going to use it. It's used to find factors of a number, which is going to be very, very useful in so many ideas in math. So this idea, if you nail it, if you really understand it, you're going to use it over and over and over and over again, right? And it's going to make you that much more confident in your math. All right, so let's go ahead and let's dive into some examples. So what we want to do here is we want to factor number 30. We want to find all its factors, and you're going to see how easy it is to use this factor tree, right? And what's going to really help you, and I encourage you to do, is to practice your multiplication skills if you need more help in them, right? So take some time and really practice those multiplication skills because it's going to make this much easier. So what we're going to do is we're going to pick two numbers, right? Two numbers that multiply to give you 30. So go ahead, give me two numbers. Perfect. If you heard the person behind you, they said 3 times, and that little dot represents multiplication. 3 times 10. Now ask yourself, right? And what's nice is you could have done 2 times 15. I did hear you, right? So it doesn't matter which two numbers that you use as long as they multiply to give you 30. So make sure you write that down. They multiply to give you 30, right? So now what we're going to do is we're going to try to break these numbers down again. So give me two numbers that multiply to give me 3, but you can't use that same number 3, right? It can't be done because what 3 is a prime number, right? 3 is a prime number. You can't break it down, right? So what I'm going to do here is I'm going to circle it. So I'm telling myself I can't break it down anymore. How about that 10, right? How about them Cowboys? How about the 10, right? Well, the 10, we could break down the 10. The 10 is 2 times 5, right? 2 times 5 gives me 10. And so now I ask myself, can I break down the 2? No, we can't break down the 2. So we circle it. Whatever number you can't break down, remember, you're circling. And then that 5, can you break down the 5? Nope. And so we circle that. And now notice there are no more lines underneath our numbers here, right? Because none of these could be broken down. So these are our factors. So let's go ahead and list them. What do we find? Well, we found the factors to be 2 times 3 times 5. So sometimes they want you to write it as a product. That just means to multiply them, right? Some of you are used to writing it like this, right? 2 times 3 times 5. I just want you to know that later on in math, this means the same thing as this, all right? So now you're ahead and you know a little bit of the secret. And sometimes they might ask you just to list the numbers. So 2, 3, and 5. So just make sure you read the instructions so that you know what they're asking for. So there's example 1. Does it make sense? Good. All right, so example 2 here, we're working with the number 81. And 81 is my favorite because I know that 81 is 9 times 9. That's one of the first numbers I learned when I was multiplying. 9 times 9 gives me 81, right? So I asked myself, can I break up this 9 and this 9? Well, of course, this 9 we know is 3 times 3. And if that's 3 times 3, then we know this 9 is also 3 times 3. Fantastic. All right, so we ask ourselves the same question. Can we break up any, well, all these are 3, so if I could break up one, I could break up all of them. If I can't break up this one, I can't break up any of these. So can you break up the 3? Perfect. So what I'm going to do is I'm going to circle it just so I know we can't break those down any further. And as you could see, there's nothing else for us to break down. So these are our factors. So our factors are 3 times 3 times 3 times 3. And if you want to be fancy, right, we could use 3.3.3.3. Just make sure this dot is high so it doesn't look like a decimal, all right? And again, if they ask you to list them, we have 3, 3, 3, 3. And what's cool is maybe some of you guys have learned about exponents, and see how these 3's are repeating? So if you wanted to use exponents, and I have a video on that. I have 3, and how many of those 3's do I have? Well, I have 4. So this right here is using an exponent. My exponent is 4, and that just tells me I have 1, 2, 3, 4 3's. Pretty cool, right? So hopefully this is making sense, but don't worry, we got more examples, so follow us. All right, so let's look at the big guy here, number 56. So if you want, you could do 2 times 28. All right, again, you could use the other numbers, but I'm just picking 2, right? Because it's easy, it's an even number, so I know 2 fits inside of it. So 2, we know we can't break down, so I circle it. How about that 28? Well, I could take half of 28, 2 times 14. And again, that 2, you can't break it up, so you circle it. How about 14? Well, you know 14 is 2 times 7, so let's go ahead and circle those, and look how easy it was, and you're finished. And what's gonna make this easier is you practicing your multiplication skills. And if you have those down, this is gonna be really easy. So our factors are 2 times 2 times 2 times 7. Again, you could put commas if you wanted to list them. If you wanted to get fancy, you have 2. How many 2's do we have? Well, we have 1, 2, 3. So that's our exponent times that 7. All right, folks, is this making sense? All right, let's do one more. Follow me. All right, so let's do 72 here. So press pause, and I want you to go ahead and take a few seconds and you try it out yourself, and let's see if we get the same answer. All right, folks, so here we go. Let's see what you got. So hopefully one of your options is 9 times 8, right? Did you have to use 9 and 8? Absolutely not. Do you have to put the dot right here? No, I'm just reminding you that 9 times 8 is 72, because a big mistake that I see is a lot of times people, they want to add these two. No, it's always multiplication. Always multiplication? Yes, even on Sunday. All right, so let's take that 9, let's break it down. We know it's 3 times 3, so we circle those 2 because we already discussed 3 cannot be broken down. How about that 8? Well, the 8 is 2 times 4. That 2, we know you can't break it down, so circle it. 4, we know is 2 times 2. And there we go, we've broken down that big number, 72. Well, how many 2's did we end up with? Well, we ended up with 1, 2, 3 2's. So we have 2 cubed, right? 2 to the 3rd power times how many 3's did we have? 1, 2. So we have 3 squared, right? 3 to the 2nd power because there's 2 of them. But if you actually wanted to list them, that's okay. And if you wanted to change the order, that's okay too, because we know for multiplication, order doesn't matter. Multiplication is what we call commutative. The order doesn't matter. All right, mathletes, hopefully this was very helpful. So don't forget to like our video, subscribe, and share this helpful video to a friend or 10,000. All right, mathletes, we'll see you in our next video. Peace.